Hello world, it's Calcutron here with the 16th episode of our TI Basic tutorial series. In this episode, we're going to unlock a powerful new tool that is the ability to create small reusable subprograms. In the past few episodes, we've started talking about optimizing our programs for size, and one of the ways to do that is to reduce duplicating code. Reducing duplicate code is one of the main goals of software engineering and abstraction, and is important for maintainability as well as optimizing programs for size. We're going to see today how this works by example. So we're going to create a new program called Clear, which improves upon our bland Clear Home functionality. So we're going to have it clear the screen with a short animation. So we're going to do that with exactly 4 for loops. In the first loop, we're going to loop through all the rows in the screen. So if you don't remember, our screen is set up as sort of a matrix, and each position in that matrix is a character. So it starts in the top left with the first row and the first column, and so currently in row 1, column 1 on our screen is the character P in the word program, and our screen is 8 rows tall and 16 columns wide. So if we loop with R between 1 and 8, and then with C between 1 and 16, that is R for row and C for column, and we display our row and our column, and we can start with, how about an equal sign, and then we'll end our 2 for loops. So we're going to fill the whole screen with equal signs, and then we're going to loop the opposite way. So we're going to loop, instead of through each column in a row, we're going to loop through each row in a column. So just switching the order of these to make a more interesting little animation. And then for each row within that, we're going to output at RC, output at R, comma C, comma, and then in this one we're going to put in a space, and then we'll end this. So this is just a little more interesting way to clear the screen. So now that we have this cooler version of Clear, we want to use it in our other programs instead of Clear Home. So let's go ahead and create a new program that could use this Clear Home functionality. So let's just have it display hi, and we'll have it prompt the user for A, and then here we want it to clear the screen. So if we run this, and I guess actually let's change test to do something a little cooler, something using what we've learned in the last episode on strings. So we can actually prompt, instead of for a number, we can prompt for strings or lists. So let's prompt for a string, and we'll prompt for string 1, and we can do it just like this, and we'll say, what is your name? Or we'll just say name. Alright, so we're going to prompt them for the name, we're going to store it into string 1, and we're going to clear home, and we'll display hi plus, and here we're concatenating strings, hi plus string 1. Okay, so if we run test now, it's gonna, oops, syntax error. Ah, yes, I was thinking we were using input. We want to use input. Good catch. So here we go, it's prompting us for our name, and we'll say Calcutron or clack, and then it will tell us hi clack, and so let's just fix that. Put in a space, and we'll tell our name is Joe, and we'll tell us hi Joe. Alright, so let's say that, oops, not this, we want to edit our program, and we want to, instead of clearing the home screen the boring normal way, we want to clear it with our cool new clear function, or our cool new clear program. What we could do is we could go ahead and copy down all that code into this program. So we could start writing for loops for R from 1 to 8, and we could rewrite all this code. We could rewrite all the for loops and the outputs. But like we talked about at the beginning, that would be duplicate code, and it would increase the overall size of our program if we're using it in multiple different places. So what we can instead do is use the third column of our program menu. So we've used our control flow statements, we've used our IO statements. In the third column, we can choose to execute the other programs that we've already written. So we can execute program clear from within our program, and this is the same way that we execute programs on the home screen. We call this program command with the name of the program, and it will run that program. And then it's important to note, when that program finishes running, when clear terminates, then it's going to come back into test and display hi plus your name. So if we run test now and we tell that our name is Bob, then it's going to use our custom clear home program and then continue our program and display hi Bob. An interesting thing about our custom clear home program is that it doesn't actually reset on the screen where the cursor is. So normally if we use the regular clear home, that hi Bob would have displayed at the top of the screen, but the calculator still thinks that we have a couple lines on our screen even though we've cleared them out, so it's displaying it in the same old place. So if we wanted it to more represent the way that clear home works, we could add a clear home call at the end, and that would reset our screen. So if we're typing things, I hope it's clear what I'm talking about. Right now our cursor is on this fourth line, and if we use the display command, it's going to display things on the next line of the screen. And clear home normally resets where the cursor is, but our custom clear home program wasn't resetting it because it was only changing each character on the screen. So now if we run test and we tell it our name is Yoda, it's going to clear the home screen and then display Yoda on the first line. Alright, so creating a subprogram like this isn't actually useful until we use it in two places. So we could create another program like test2, or we could use it in our thumbnail program. So this is the thumbnail program. It's pretty straightforward. It just outputs on the screen the thumbnail of the video, and then it pauses, and then when it finishes it clears the home screen. What we could do is take this and then go ahead and execute clear in every place that we have a clear home. I guess now that you've seen it, this is a good time, as good as any, to briefly talk about how you get rid of the done message. So I talked about a couple programs ago, or maybe 2 episodes ago, how if you end your program with an expression, that it will output or it will display that expression right before your program terminates in place of the done message. So if this was 4 plus 4, when we run our thumbnail program, it's going to clear the home screen using our custom clear home, and then when it terminates, it's going to output 8 instead of a done message. So if we didn't have that expression there, it would give us a done message, which some people don't like. Some people think it's annoying, and I guess I've started to agree with those people because I've disabled the done message. And the way you do that is you give it an expression, but that expression is a blank message. So that could be a string with a bunch of spaces in it, but if you leave off the end quote and you only put one space, it looks like it's just a single quote. And when you run the program, it appears as if there is no done message at the end. So now you know exactly how the thumbnail program works, and now we have it using our custom clear. So that's pretty cool. So one of the main benefits of using these subprograms, besides reducing the size of duplicating this over and over, is that if we want to change something in clear, let's say instead of using the equal sign we want to use an O, we can change this in one place And then everywhere that we use this clear program, it's going to be updated. So if instead we had duplicated that code all over, what would happen is we'd have to change it in, right now, 3 places. If we used clear in every single one of our programs and we wrote a lot of programs, it could be used in dozens of places. And if we had instead duplicated that code and not used a subprogram, we would have to go in and find every place we duplicated it and change that individual piece of code. So that's why software engineers who write a lot of software and they do it for a living, that's why they want to reduce duplicate code, or it's at least one of the reasons, is so that changes in one place can affect how your entire program runs, or how multiple programs run in the case of a subprogram like this. So in the next episode, we're going to look at another way that we can write small reusable pieces of code that doesn't involve us creating a new program. So oftentimes I like to use the way we're going to learn in the next episode over this way, because I don't like to add a lot of clutter to my program screen. And if you have a lot of subprograms and you want to reuse your code frequently, which is a good idea as long as you're using a subprogram or a function, if you have a lot of those, it can start to clutter up your program screen with a lot of programs that just do very small actions. And if you're starting to write larger and larger programs that need more and more subprograms, it can start to get cluttered. So I'm going to teach you a new way in the next episode that doesn't use this subprogram feature. So stay tuned for that, but if you have any questions or comments, please leave them below. Hope you enjoyed this episode. Bye-bye!